Hello guys, so we'll be solving optimal partition of a string today. So let us first read the problem. Given a string S, partition the string into one or more substrings such that the characters in each substring are unique. That is, no letter appears in the substring more than once, right? And we have to return the minimum number of substring in such a partition. Okay, so basically what the question states that we have a string S and we have to partition this string into some number of substrings such that each substring contains only distinct characters, right? So what is the question states that if I try to see from the first example is A, B, A, C, A, B, A, right? We have this example. So I hope you guys already know what a valid substring is or what a substring is. Substring is known to be the continuous part of the string, right? So this is a substring. This is a substring. That is BAC is a substring, right? CAB is a substring. Okay. So these are some of the valid substrings. Okay. So what we have to now see that we have been given this string, right? So we have to partition the string in such a way that every substring contains a valid every substring contains distinct number of characters, okay, or distinct characters. It should not contain repeating characters. For example, first I will go to A, okay, or let us say if I take AB. So can I consider A as my string or a substring? No. Why? Because A is already present once, so it is repeating two times. So what can be a greedy approach is that I can just store the frequency every time I'm visiting my characters, right? So I'll just quickly explain the algorithm first. So what I'm going to do is, first I can take, for storing the frequency, I can take any data structure such as map or set. Okay, so let us say for instance we are taking set for in this example. Okay, so what I can do is at every step, okay, at every step I will iterate through this string. I will iterate through the string and I'll go to every character, okay, and I'll initialize a counter variable as 0. That is, till now I have got 0 substrings. Okay, so what I can do is every time I'm visiting a character, I can store its frequency inside my set. Okay, so let us say we have a set variable. So first I went to A, I will store it in my A. Okay. Now I'll go to the next character, that is B. I'll check if my B is, if at all it is present in my set. So if B is present, if it is not present in my set, then I will again push it inside my set. Okay. I'll insert it inside my set. Then I'll again go to the next character, that is again A. I will check at this index whether this character has already appeared in my substring, which I'm considering right now, right? So we can clearly see that the set contains character A, right? It already contains character A. So what we can do is we can just empty the set. We will empty the set. We will empty the set. Now set is reinitialized. That is, this is for considering the next valid substring, and I can just state that counter plus plus. That is, I have got one valid substring. Okay, one partition such that I can take from here to here. This is a valid partition. Valid partition. Okay, so if I try to just iterate through the first test case using this algorithm, what I'm basically saying is that first I have a set, okay, and I have a counter variable as 0. Okay, so first I will go to the first element. Is it present in my set? No, it is not present. So we'll insert it. Then I'll go to next. I'll go to the next index. I'll see if B is present in my set. So no, B is not present. So I'll push it again. Then I'll go to A. Okay. So what I'm seeing is A present in my set or not? Okay. So A is already present in my set. So that means it is repeating. in this substring till now, whichever valid substring I'm considering, the A character is repeating again. Okay. So what we can do is we can just empty this. That is, this is a valid substring. After this, we cannot take any continuous character, and we'll just reinitialize the set, and we'll do counter plus plus. Okay, so now my counter becomes 1. Okay, my now my counter becomes 1. Then again, we are at this index, and we'll push this element. That is, now from here this was a valid substring, and now from here I'm considering a new valid substring. Okay, so now we went to A. Is A in my set? No. Then I'll push it again. I went to C. Is C in my set? No. Push it again. I went to A again. So now if we see, A is already in my set. Okay, so now what we can do is counter plus plus. If we do counter plus plus, now counter equal to 2. That is, till this index, we have got two valid substring, that is AB and AC, right? So we did, and we will reinitialize the set again. So now we are at this index. We'll push A. Okay. I went to B again. I'll push B. Why? Because it is not present in my set. I'll push it. And then I went to A again. So now we will see that the now we can see that it is already present in my set. So what we can do is, again we'll do counter plus plus. So now my counter becomes 3. Okay, see, AB, and this is the valid substring. Again, what we got, AB is a valid substring that we got, and we are at the last character, right? 3. And we will reinitialize the set. Now set is empty. Now we got A here, and we'll push A because there was no element present in our set. And at the end, when the iteration ends, that is when I reaches n minus 1, I will again do counter plus plus. Why? Because whatever is the remaining element in my set, it becomes a valid substring. So what are the valid substrings we got in this first test case? AB, AC, AB again, and then A. Okay, so we'll be quickly coding this out. Let us say we have an unordered set of of char. Okay, so what I'm doing is I'm iterating through my string. Okay, and I'm checking if my st dot find sfi is not equal to st dot end. That is, if at all this element is not present in my if at all this element is already present. Okay, if at all this element is already present, what I can do is I will just do counter plus plus. Okay, counter plus plus, and I will clear my, or I will empty my set. Okay, I'll do this. Else, if at all, if the element is already present in my set, then what I can do is, if it is not present in my set, then I will just insert it. At the end, I am doing counter plus plus for remaining elements. Okay, and we'll return the, sorry, the counter variable was not initialized.